Hi, welcome back. And today we are going to discuss about the real power, reactive power, apparent power, and power factor in AC circuits. So, what is power in AC circuit? So, normally in DC circuit, the power is equal to P is equal to VI. That is voltage and current. But in the AC circuit, in AC there are three components. One is called real power, that is called actual work done, and the second one reactive power, the energy stored and it will be returned back, and the third one apparent power, so the total power which is supplied. So while doing the empathize about the AC circuits of the various powers, so there are several questions. The number one, why does my fan consume power even when just humming? And the second one, why do industry pay extra charges on electricity bills? And the third one, how can apparent power be greater than the real power? Okay, so these are the several questions while doing the empathize. So in the defense stage, we are to struggle to visualize the invisible power component like active power, reactive power, and apparent power. So just you can see the image. So this is nothing but a generator, it's generating the voltage. So the generated voltage that will be supplied to the load, but here it is unable to supply to the load. But you can see here in the next image, with the help of reactive power support, we can able to transfer the electrical energy from the generator to load. So without reactive power, we are unable to transfer the electrical energy from one place to another place. And in the ideate stage, just you can consider this is an cool drinks bottle. This is a glass tumbler, and I'm opening the Sprite 7 Up or something, and it will be used in the glass tumblers. Okay, so here the total volume is called an apparent power. The total volume is called apparent power, and the active power, true power, real power. That is nothing but the net amount of cool drinks. The net amount of cool drinks which is available to drink, the net amount of cold drinks which is able to drink, that is nothing but an active power. And so above this pot there will be an wastage, there will be an wastage will be there, so we are unable to drink this pot of the volume. So this is nothing but reactive power. So the total is nothing but the total volume is nothing but apparent power, and the amount of cool drinks we can able to consume is nothing but active power, and the remaining part it is unable to drink, so this is nothing but an reactive power. Okay, so the active power can be measured by using a formula P is equal to VI cos pi, and for the reactive power, so it is not an useful power. Okay, so that can be represented by Q is equal to VI sin pi, and the apparent power which is measured S is equal to just voltage into current. So in the power factor, so what is power factor? So the power factor is nothing but a ratio of real power to the apparent power. It is a ratio of real power. Okay, the real power is nothing but active power. So it is a ratio of real power to the apparent power is called an power factor. Okay, now you can see if the power factor is 0.7, so there will be an reactive power will be there. Suppose if you are using some of the reactive power compensation method, the power factor 0.7 can be compensated into unity. Okay, so we can able to save this energy. We can able to save the energy. And this is the mathematical analysis. The instantaneous power P is equal to voltage current. So that is nothing but with respect to time. So Vm sin omega t into Im sin omega t minus pi. And the average power can be measured by using the Vi cos pi. So voltage and current both are in RMS value. And the reactive power Vi sin pi, and voltage and current will be in RMS value. And the complex power can be the apparent power is equal to real power plus reactive power in complex form. So this is a real world applications of the various type of powers in AC circuit. So it can be used in the industrial motor like it may be a 5 HP motor or 7 HP motor like that. And according to the power factor, the real power is get changing. And in the power distribution side, so in the utility, we are installing capacitor bank to improve the efficiency to compensate the reactive power losses. And in the smart building, we are using the automatic power factor correction. So it also used to compensate the reactive powers. And why power factor matters? Because 20% line loss reduction can be achieved, and 15 lakh rupees of annual saving can be achieved by using the power factor correction. So 30% capacity gain can be built by using the for transformers and battery power factor. And this is a mind map about the various types of power. So the kit can say it may be in a real power, reactive power, apparent power, and power factor. So real power, it can be measured in watts and associated with a variable resistive load. Okay, it is an actual work done. And the reactive power is nothing but it is measured in volt ampere reactive, and it is mainly depends on the inductive load. And it is associated with capacitive load also. And the apparent power, it is measured in volt ampere and represent the total supply. And it is conceptually related to the power triangle. And the power factor is nothing but it is a ratio of real power to the apparent power. So this is a curative challenge. If a capacitor does not consume real power, why does connecting it to an inductive circuit reduce your electricity bill? So you can think and answer in the comment sections. So this is an assessment. An industrial load consume 50 kilowatts at 0.7 power factor lagging. So what capacitor rating in kilovolt ampere reactive is needed to improve the power factor to 0.15? So you can imagine and you can calculate and you can put in the answer in the comment sections. And these are the few references for this topic. Thank you.